Hi everyone, this is Jeff West. Thanks for joining us. This is the first session in a 5-session series of Webcast targeted at Java developers who are working with WebLogic. The ultimate goal of the series is to show you how to build a composite application that has RESTful web services that are exposed and consumed by a JavaScript UI with jQuery. And that'll happen in the fourth session. In the second session, we'll show you how to use a distributed caching technology called Coherence and integrate that with JPA. And in the third session, we'll talk about web services and message-driven services with Spring and contrast those with just core Java web services and MDBs. Then finally, in the fifth session, we'll go over troubleshooting and tuning for web and JMS services. So with that, I'll turn it over to Sean Smith, who is a product manager in Toplink, and he'll walk us through the first session.
Hello, and welcome to part 1 of our WebLogic Developer Series. In this section, we're going to talk about data access with JPA. My name is Sean Smith. I'm a product manager with the Oracle Toplink team, and my colleague Sohail Dadani will be doing the demos for us today, showing the tools we have in OP for JPA development. So what is JPA? So in a nutshell, it's a standard, Java standard for defining how Java objects are stored in relational databases. It gives you a simple API for reading and writing those objects, which we refer to as entities. Persistent objects are entities. A query language called JPQL. And it also supports a contract to interact with EJB containers. So Java EE 5 and 6 containers both support plugging in JPA. If you take a look at the diagram on the right-hand side of the slide, you'll see the sort of the parts that are involved with this. So we have Java classes and a database schema that we're ultimately wanting to store our objects into, and we provide in JPA some sort of persistence metadata that's used to define how those Java classes go into that database. And in your application, whether SC or EE, your application talks to the JPA API, which ultimately talks to JDBC driver to read and write your objects. So a bit of background on JPA. It was a standardization of practices that were commonly used in industry. So a lot of people were using things like Hibernate and Toplink to do Java persistence, which is focused on POJOs. So those of you who've been around a while know there was a previous specification, EJB 2.1 Container Managed Persistence, which is quite dissimilar to JPA, but was the technology in Java EE, which really people weren't using widely because of its complexity. And in response, products like Toplink and Hibernate appeared, and they defined the standard of how these things should be done. So basically POJO persistence. So those approaches, the approach of POJO persistence was standardized in the JPA spec. It was included as part of the EJB 3 specification originally, sort of a sub-specification, but it was spun off now in JPA 2 is JSR 317, it's its own specification, so it's a standalone technology. Although it's associated with EJB and Java EE, it's actually usable in SE also. Toplink is Oracle's JPA implementation. It's based on the open source EclipseLink project, which was a project founded by Oracle and started with the contribution of the original Oracle Toplink source code. So this is a very mature code base that's being used by many enterprises in large-scale applications. It is certified on and is shipped as part of the Oracle WebLogic application server. So all versions of WebLogic do include Toplink and come with EclipseLink JPA. In addition to the EclipseLink code that's included in Oracle Toplink, there's also Toplink Grid, and that provides integration between JPA and Oracle Coherence. And the purpose of the Toplink Grid is to support scaling JPA applications into very large clusters. So if you're not familiar with Coherence, I encourage you to go to the Oracle OTN website and look up Coherence, but it's a data grid product that really lets you scale applications into very large clusters. And we have development tool support in Eclipse OP, which we'll see today. It's also support in JDeveloper and in NetBeans. In JPA, we map classes. We talk about mapping. It's an activity where we connect or associate Java classes with tables. Now in the diagram here, I have a very trivial example. A simple customer object with about 2 or 3 attributes that are going to map to a table similar name with similar columns. And now obviously this looks very trivial, and in fact it's It's very straightforward to configure this in JPA. There's actually very little to do because of the reliance on defaulting behavior. But it gets much more complicated if you have a very complex database schema or object model. But all the support's there in JPA, but this is the basic concept for mapping, associating your classes with the tables you're targeting. And here's what it looks like. Here's a class with some annotations on it. I can put an @entity annotation on a customer class, and now that identifies this class as a persistent object. I do need to define the primary key, so I need to say what ID or what field uniquely identifies this object, and it will map to a database primary key column. And you can see here I have one more annotation I've thrown in this example, a one-to-one, which identifies that an account or a customer has a one-to-one association with an account. This is very straightforward. That's actually all it takes to persist this customer object. Very little metadata needs to be defined. Another alternative to mapping is to use XML. So for those of you who are not fans of annotations, there's a way to capture all that metadata in XML. And you'll see here that this document captures exactly the same information as we saw in the annotations. We identify a class called customer, we have a list of its attributes that are being mapped, and we see that name is identified as the ID. So it's very similar to what you saw in annotations. What's also interesting with XML is it can be used as an override mechanism, which is really the principal intent of this technology or this approach, which is you can use XML to override mappings that are defined in source. So someone gives you a jar with Java annotations, Java classes with annotations on them that are compiled into bytecodes. The only way for you to customize those mappings, perhaps your database tables are named differently, or then you can use the XML mapping file to override those mappings. So in JPA, there are three typical development approaches. Bottom up, in which you're beginning your development of your application, and you have a database schema. So you're building an application on an existing database, and you can generate JPA entities from those database tables. And there are tools in OP that are provided that will actually do this for you. You can customize the generation. You can identify the tables you want to select from or build entities from, and the target package you want to generate into, and so on. And this is actually a really good approach for sort of bootstrapping your application. Start with some tables, generate some classes, and then move from there. I don't recommend this as the way to work every day. This is a good bootstrap, and I emphasize bootstrap, because really the classes that you get when you generate them from tables look like tables. There's no inheritance being made use of as you would in Java typically, no polymorphism. Really, it's projecting, the objects are projections of those tables into Java. And so what you tend to do in this approach is generate the classes and then adjust those classes to be more object oriented, and yet still map to those tables. In a top-down approach, you have some Java classes, and you can put some JPA annotations on those classes, identify them as persistent objects, as entities, and then you can actually generate the tables that map to those classes. So this is a nice way if you're in a greenfield application development scenario, where you can focus on a really good Java domain model and then generate the tables that would let you persist the objects from that domain. So this is actually a pretty good approach. And typically what you see in sort of real-world applications, this is how many application developments get started. And at some point, the SQL or the DDL that's been generated by tools like EclipseLink, which we'll see here, are handed over to the DBAs, who typically tweak that SQL, the DDL, and come back with some minor changes. The third approach is meet in the middle. And a meet in the middle is actually fairly typical. You find that this is a case where you have existing database schemas, and you want to come up with just the right Java object model. And you're really connecting existing classes to existing tables by providing the right annotations or the right metadata. This approach is actually most common because really it lets you focus on getting it right on both sides, right, on the data model side and the Java object model side. And it can actually be sort of a step 2 of a development process where you start with a bottom-up or top-down. And I kind of alluded to that in the bottom-up approach, where you generate some classes from tables and then proceed to really make those classes more object-oriented, or your domain model more object-oriented. You've essentially entered a meet-in-the-middle approach, where as you change the classes, you're going to adjust your mappings to continue to map to those same tables. So, and same in top-down. You may generate some tables from classes, and then your DBAs come back to you with some changes, and you have to adjust your mappings. So ultimately, you typically end up in a meet-in-the-middle scenario, regardless of which way you really begin. So in our scenario, we have a fairly unique scenario in that we're building a simple JAX-RS fronted application. And on the back end, we've got a relational database. So we're going to have, calls coming in through JAX-RS that are going to access relational data. And of course, this is Java, so we need technologies on both front and back ends to make this work. So in this scenario, we're going to start with an XSD, and that XSD is going to describe the documents that we're going to interchange right through a RESTful API. This is a bit slightly different than the scenario we described before, all the various approaches, as it's a slight twist in that we're going to actually take the XSD and compile it with the JAXB schema compiler to generate the POJOs. So our POJOs that we're going to work with are actually going to be derived from the schema itself. And so we're going to be using JAXB later on in the JAX-RS component of this series to marshal the Java objects. But for now, we're going to just sort of focus on the fact that we're going to generate these classes from a schema and then work from there. So this is going to be a top-down approach, modified top-down. We generate the POJOs, then we add some annotations to these classes to make them into entities, and then we're going to generate the database schema that those classes map to.
Our object model is structured such that we have a base object class that has the primary key ID. Every entity record will need a unique ID. There are multiple methods to generate unique IDs. In our example, we will use sequence, which is the most portable among databases. The base entity class extends the base object class and has the required createDate and modifyDate attributes. Every entity record has these values. The address class and shipment class extends the base entity class and inherits the required attributes. Also, the shipment class has a collection of parcel objects. As a result, when a shipment class is persisted, so are the associate parcel classes. So let's first create a new project, a JPA project. And click Next. The name of our project will be OPS JPA, and we will keep the default settings and click Next. Click on the Add folder here. We want to keep the POJOs generated from JAXB separate from our custom source code. Later in this exercise, we will create a custom listener class. Click OK and click Next. For our platform, we will use Eclipse Link 2.0.x. We also want to create user libraries here, and the libraries that we want to add here are the jars for Toplink. So I'll click on this icon here. We'll click on New, and the name of our library that we'll call it Toplink. Let's add jars to this library, and all of my jars happen to be in this directory, and I will go ahead and select all of them. Click on Open, OK, and ensure that there's a checkbox right next to the Toplink library that we just created. Let's also create a connection to the Oracle database by clicking on the Add Connection. Since our database is Oracle, let's scroll down and select Oracle from here, and we will call this Oracle as well. Click on Next, and you'll notice that the Oracle default driver is selected. My SID happens to be XE, and the database happens to run on my laptop here, so the host will be localhost. The username has to match the one that we had created earlier within Apex, and so you'll recall that our database user is OPS JPA user. Password is welcome1, all lowercase. click on the Save Password, and let's also press the Test Connection button to ensure that our connection string works and that we're able to communicate to our database. And you'll notice that our ping succeeded. We'll click on Next here and keep this and click Finish. Finally, let's also click on Add Driver to the build path and click on Finish to complete our project settings. Now let's configure the persistence.xml file. This file contains various settings, but we're interested in the transaction type, database connection, and logging. The persistence.xml file is found under the meta-inf folder. JPA provides two mechanisms for transactions. When used with an application server such as WebLogic, JPA provides integration with Java Transaction API, or JTA. When transactions are managed by a non-JEE application, JPA also provides its own entity transaction implementation, which is referred to as Resource Local. Since our application will not be deployed on an application server, we will use Resource Local as a transaction type. Next, we want to make a connection from OP to the database. And so click on Populate from Connection link, and it will bring up the different transactions or different database connections that are available. And you recall we had created an Oracle connection. Click OK, and these fields will be automatically populated. The next area of interest is logging. So let's click on the Logging tab, and here OP provides various different levels of logging. By default, it is set to Info, but what we want to do is select Fine. You'll also notice that there's quite a bit of other information that can be logged, whether it be timestamp, the different threads that are accessing the database, session, exceptions, as well as the connections that are there. You can also select a logging file or select Standard Out. For our application and for testing purposes, we'll just write to Standard Out. In addition, there are further logging categories where you can select the different levels of logging information that you'd like. For the purposes of this demonstration, I will leave the defaults the way they are, and I will also reduce the amount of logging information that gets logged to the Standard Out so that it's clearer and easier to read. Next, let's save the persistence.xml file, and now we're complete. There are two XSDs and one binding file supplied with our sample application. The shipping XSD file is the main file. It is the file that references the common XSD file. We've extracted common attributes among all entities and placed them in this file. The common attributes include an entity ID, the create date, and modified date. JAXB by default creates a Java XML Gregorian calendar class for all date attributes. The binding file exists to convert the default date data structure into the Java util calendar date data structure. Here we see the contents of the bindings.xjb file. Notice that there are two different methods to parse, one to print, one to parse, and it results into the Java util calendar date class. Our next task is to create POJOs from the XSD. The XSD is part of the resources that you can download. We will first create a XSD folder and copy our files there. Then we will use OP and JAXB to generate the POJOs. We'll call the folder XSD. Next, we will import the file. It's going to be a file system. Expand this XSD directory and select the shipping folder as well as the common XSD. Then click on Finish. We want to next create the POJOs. So the POJOs, in order to do that, expand on the XSD, expand the shipping folder, and then pick shipping.xsd. Right click on it and click on Generate JAXB classes. Since this code is generated, we will store it in the source-generated folder. Our package will be com.oracle.demo.ops.domain. There's also a bindings file included with the resources. Be sure to include that here as well. Bindings file is found under XSD, Shipping, and Bindings.xjb. The purpose for the bindings.xjb file is that by default, JAXB parser creates XML Gregorian calendar class. What we want to do is replace that with the standard Java util calendar class. And this bindings.xjb class, as a result, creates an adapter class that replaces the calendar class that's required for our code. We will then click on Finish, and you'll note in the console that a set of Java files have been now created. To see the files that have been created, what I'll do is I'll click on the project, refresh it, and you'll notice that the package that we had put into the dialog box, as well as all the different classes that are needed, have now been generated and are available. The OR mapping file contains object relational mappings and can override annotations. For every annotation JPA provides, an XML equivalent descriptor is also available. Therefore, an application has the option to have either annotations or XML descriptors, or a combination of both. For our sample application, we have decided to use both. The orm.xml file is stored under meta-inf, the same location as persistent.xml file. What I'll do next is create the orm.xml file. To get started, first let's ensure that JPA structure and JPA details panels are available. In order to bring them up, what you simply do is click on the window menu, Show View, and select JPA Details and JPA Structure. These two panels provide the necessary tooling to create the orm.xml file without having to edit the file itself. The first thing we'll do is bring up all the entities and then thereafter add the attributes. We have two superclasses, a base object class and a base entity class, and then thereafter entity classes. In order to override an attribute, we first select Add Attribute to XML and make changes in the JPA Details panel. In this example, we want to set the attribute ID as a primary key. The createDate and modifiedDate are two attributes in the base entity. Both attributes are timestamps. The parcel status is an enumerated attribute of strings. The enumeration is kept in the database. The date attribute in the parcel log event entity will be mapped to a column called event_date. The last entity that I will modify will be Shipment. It has a named query associated with it. This query is embedded in the file, and it will retrieve shipment objects that match a given external reference ID. The shipment table and the parcel table have a one-to-many relationship where for every shipment there can be one or more parcels. We want to retrieve parcel objects sorted by ID, so I will just type it in. there is a one-to-one relationship with to address and from address. Our final step is to make reference to a listener class, and I will need to type it in. This completes our orm.xml mapping file. The last thing we want to do is save it and close it. Our final step before we create the database tables is to import a shipment listener class. We are adding the listener to propagate the ID of the shipment to the parcel once it has been assigned. Typically, this would not be necessary due to our use of JAXB-generated classes. Since the listener class is custom code, I will import it in the source folder versus the source-generated folder. The next step is to create the database schema and tables. I will now switch over to the SQL Data Explorer from OP, and we can see the tables that have been generated. And you'll note the tables here were all created through through OP. Let's now write some code to persist shipment as well as parcel objects. We'll first start off with a helper class that I've created called example. I'll paste that code in rather than write it out. Save it. Next, let's create a class called Shipment Service. And we'll paste the content again. We have some import statements. We're using the standard JDK logger, and we need a value for the persistent unit, which is found in the meta under meta.inf and in the persistent.xml file. The value we need is OPS JPA. There are a number of different methods that we've created here: finder methods, insert methods, update methods, and at the very bottom I have a main method which is going to rely on the example helper file that I created to persist shipment records. Now in this example, we are not only inserting shipment records, but we're also going to insert parcel records. Let's save this file and run it. Next, I'll switch over to Application Express. And let's run a query on the shipment table. And you'll notice that we've inserted one record, the primary key being 101. Now we've also inserted a couple of parcel records, so let's run the same query but on the parcel table. And you'll notice that there's a primary key of shipment 101 on two parcels associated with the shipment that was sent earlier. Eclipse OP provides some great tooling when it comes to editing the orm.xml file. What I want to show you next is how to actually edit the file without having knowledge of the XML descriptions and descriptors. The first thing we want to do is ensure that we actually have a database connection from the IDE. So ensure that Data Source Explorer is available for you, and I'm just going to right click here and make sure that the connection is active. The next thing you want to make sure is that we scroll down and ensure that the tables that we've created earlier exist, and as you can see that they're there. The next thing that we want to ensure is that you have the following two panels, the JPA structure as well as JPA details. In order to have these two appear, all you need to do is go to the window menu and select Show View, and then of course select JPA structure and JPA details. To show you the tooling, what I'm going to do is actually work with the orm.xml file, bring that up first, and next I also would work with the address.java class, and I'll bring that up so that we can flip back and forth between the two. The tooling within the IDE allows you to make modifications to columns as well as attributes. What I'm going to do is scroll down here, and you'll notice that we have the element or the attribute city. What if the actual value in the database was different? And so it's very easy to actually click on JPA structure, click on city, and you're able to make modification here. And let's say the actual name of the column city is actually __ city __, and if I hit enter, you'll notice that the IDE automatically includes the annotation at column and puts the proper value in that we actually put in on the JPA details. When I save this and go back to the orm.xml file, you'll notice there's an error. What's happening here is that the IDE is actually going against the database connection that we have established earlier and validates whether a column with the name that we actually typed in earlier matches in the database table. And so it's much cheaper to determine this during design time, and it's much more expensive to determine there's an error during runtime. If I hover over the actual error, it tells you that the city column does not actually exist. Let's go back to the address.java class and remove this. What we'll do is go back to the default value. And so you'll notice that the annotation has now been removed. I'll save the file, go back to orm.xml file, and you'll notice that the error is now gone. What if you need to map an existing attribute to a new or a different column in the database? The IDE can assist you with that as well. What I'm going to do is map the city attribute to a different column in the database. On the JPA structure, I'll expand address, right-click on city, and select Add Attribute to XML. You'll notice right away that the editor updates the orm.xml file and selects or types in the existing column that we're mapped to. Next, I'll switch over to JPA details, expand basic, and here you'll notice that all the lists that are available under the address table are shown. What if I wanted to make a modification here and have the city attribute be mapped to address line.1? So my option, and the best option, would be to come to the orm.xml file and make that change. And you'll notice the editor now says that wherever city is, the values are going to be stored in address.xml. It's automatically validated. There are no errors because address line 1 is a valid column within the database. The alternative would be to go back to address.java and make the change in the source code and actually add an annotation. But this may not be feasible during runtime where you're not able to make changes to your source code. And so the most appropriate and less expensive method would be to make an override change within the orm.xml file. Let's go back to city and replace it to what it was before, which is the city column itself. Although there's a list of columns available here, because we have a database connection, I do not have to select any one of these. I can simply have typed in a different database column as well. So for example, if I wanted to type in our previous example, which is __ city, and __ again, the IDE will actually accept it. However, because I have a connection to the database, as soon as I come over to the editor and save the file, the IDE will go back to the database and validate whether this column exists. If I hover over the X, you'll notice that it says that it's not able to find this match. And so again, another validation that we're able to do within the IDE at design time versus runtime. Let's go back and select city again, and so that our file is now clean and our examples will now work.
So again, thanks for joining us. In the next session, we'll talk about distributed caching with coherence. We'll show you how to integrate coherence with JPA and also how to manage coherent servers and clusters from the WebLogic admin console. In addition, I wanted to share with you guys a link to the Oracle WebLogic YouTube channel. Here you'll find videos produced by me and other members of product management on technologies like advanced JMS with topics like unit of order, unit of work, and store and forward. A few recordings about JRocket mission control, and some other. I also wanted to share a link with you. I also wanted to share a link with you to the WebLogic YouTube channel. Here you can find videos about different features of WebLogic. We have videos on different advanced JMS features, WLST, how to use WebLogic Server with Maven and Eclipse, and several other things that were hopefully relevant to the community. And also, on the channel, on the YouTube channel, there's a section for you to add comments and suggestions of things that features you'd like to see from WebLogic. So stop by and vote on one of the existing suggestions or make a new suggestion for something that you'd like to see from us. And now we'll turn it over for questions.